this is my 10th take at this. So no matter what happens this time, I'm submitting this one. Hello, my name is Hunter, and these are 2 amino acids. I'm going to talk about the general overview of what an amino acid is made of in terms of its like chemical structure, and then I'm going to talk about how to put both of them together, like so, but more, and then we'll see what happens after that. Okay, I'm back. So I'm not going to do fancy transitions because I don't know how, but I have a sticker on my laptop that goes back and forth, so that's how I'm going to pretend to do scenes. I'm not going to do that again. So anyways, you have an amine group on your amino acid, which is where you have a nitrogen, which is this blue ball, connected to 3 hydrogens. This is what gives your chain a partial positive charge, is that 3rd hydrogen. So your nitrogen, your amine group, is going to connect to this alpha carbon here, which is this black ball. And then your alpha carbon is going to be connected to your R group, which can be essentially anything, so I'm not going to define it here. Your alpha carbon is then going to be connected to this other carbon for your carboxyl group, which is going to be the C terminus of your amino acid. Your carboxyl group is going to have a double bond to an oxygen, and then there's also, on your C terminus, there's going to be another bond to an oxygen. This is going to give your chain a partial negative charge. So you got partial positive over here at the N terminus, partial negative over here at the C terminus. Sorry. And then if you were going to make a chain of amino acids, like a polypeptide chain, the way those would connect would be by taking a hydrogen off of your amine group. So, and then you take this guy off, take your oxygen off of that 2nd carbon on your carboxyl group, and it's going to connect here. Now this bond that used to be that 3rd hydrogen on this amine group that just connected to this carbon, this is your peptide bond. Because of the oxygen, that oxygen should stay here ideally, but this little structure, like the one I just threw, the oxygen that was here before, that would stay here and create partial resonance with something, and then it would basically make it so this bond right here had a partial double bond character. So these bonds, this bond here can't rotate about, because you should imagine another, like a double bond here, right? So it can't rotate. This bond and this bond can rotate though. So this is where we get into psi and phi bonds. Psi and phi bonds, yeah. So your phi bond is going to be between your nitrogen group and your alpha carbon. So that's this right here. This can rotate. Do a little woohoo, a little funky dance. This guy is your psi bond, which is your alpha carbon connected to your carboxyl group. Also can do a little funky dance. You know what I'm saying? So that is essentially what would happen, what does happen when amino acids to make a... Good luck.